When I solve for angles, I'm going to use the inverse. So on 23, I label my sides O, no H, A. Tangent of some angle equals O over A. In order to solve for that angle, I use the inverse, which moves the tangent over to the 15 over 22. That means I have to push that second button, tangent, to get that inverse, 15 over 22. My angle, if I round it to degrees, will be 34 degrees because that 2 won't round up. 34 degrees for my missing angle. If you don't want to use a theta in there, you can put x. So on 24, let's say I want to use an x. No opposite, hypotenuse adjacent. Cosine of x equals a over h. To move the cosine over, I use the inverse, which gives me second cosine 42 divided by 45 is 21 degrees. So no matter what variable or symbol I put in the parentheses, I can solve for that missing piece. 25, opposite hypotenuse. Sine of x equals O over h. I enter the inverse, second sine, 44 divided by 58, 49 degrees. Opposite hypotenuse, sine of x equals O over h. Do the inverse, second sine, 21 divided by 35 equals 37 degrees. This time it would round up because of the 8. No opposite, hypotenuse adjacent. Cosine of some angle equals a over h. I use the inverse and get the missing angle of 5 over 8 equals 51 degrees. Opposite hypotenuse is sine of something equals O over h. Inverse it. Second sine, 17 over 20 is 58 degrees. Last two, opposite, no hypotenuse, adjacent. Tangent of something equals O over A. Use the inverse. Second tangent, 29 divided by 30 equals 44 degrees. No opposite, hypotenuse adjacent. Cosine of something equals A over H. Second cosine, 30 divided by 51 is, I'm going to show my work, 54 degrees. And that is how you solve for missing angles.